viewers, welcome to my channel. I had this question from a colleague of mine. He's throwing a challenge that we should play around this question. We have to find the dy dx of y equals to sine x plus cos x divided by sine x minus cos x. If this were to be plus, the whole thing would have been 1. Or if this were minus, the whole thing would have been 1. So I want us to use the quotient rule to solve this. So let's just say the numerator will be represented by u, and that will be the sine x plus what? The cos x. Then your v will be the denominator, the sine x minus what? The cos x. I believe we can recall the rule of product rule, which says that dy dx will be equals to, first of all, find d du over what? Dx minus u dv over what? Dx, dy dx, all this divided by what? U square. So we know the v and the u already. We just need du dx and dv dx. So right away I find my du dx, du. Okay, here is it. If we differentiate a sine, what do you get? I believe we get a cos. Then we have plus. If we differentiate a cos, you get a negative sign. So this will be negative sine x. That is all. Then dv dx will also be differentiate a sign, which will still give us what? A positive cos x. If we differentiate a cos, you get a negative sign. So negative give you plus what? Sine x. So now we do our substitution, putting this and this in this place, then v and u in that place. I think my board is too small, but let's check how best we can do that. So I will ignore dy dx and go straight with what? My v, which is going to be sine x minus cos x. That is multiplying du dx. So that will be cos x minus sine x minus this minus. What is our u? U is going to be the sine x plus cos x multiplying dv. Where is my dv? And that will be the cos x plus what? The sine x. Don't forget, this is a fraction divided by v square, which will be sine x minus what? The cos x. So what do? We do our manipulation with the numerator. Sine minus cos, cos minus sine. We can manipulate that. Sine plus cos, cos plus sine, which is the same. Sine plus cos, we can change the position. So if you have your a plus b multiplying a plus b, you know there are two brackets. So a plus b square will be easy to write. So the whole of this will become sine plus cos square. So since I have that, I will try to manipulate the top to get the same thing. I'm seeing cos, sine, cos, sine. So I would like to have the cos to come first, to be like this. And that means if I put a negative before and put the cos, it will still be negative cos, right? Then if I put a minus sign with the negative going in, will still make the sign to become what? A positive. So instead of writing this, I can write this multiplying cos x minus what? Sine x. And we can see this and this is in the same domain. Just that in this case, the minus will come before the bracket. So you can see cos minus sine, a negative will come, cos minus sine. Alright. I'm trying to manage the blackboard, so let's go with that. So this will be minus cos x minus sine x all square then minus, which is this. This will be cos x plus sine x all squared. Then we still divide by what? Sine x cos x all squared. Alright, we can also recall under algebra that if I have a plus b, whether it's minus squared, it's going to be square the first a squared, then plus b squared, then plus 2ab, twice their product, right? If it is minus, then here will be minus. So in the case of this will be a minus. In the case of this, it will be positive throughout, right? I still need a bigger board, right? But let's see how we can do that. I'll use line after line. So right here, I maintain my negative, then bring the bracket. So if I square this, let me introduce this first. If I square this, it will be cos square x, then it will become plus sine square x, then minus 2 cos x sine what? X. You get that, right? Square the first, twice their product, square the last. Alright, then our minus sign will come. Square the first, which will be cos square x plus sine square x plus 2 cos square x sine square x. Don't forget, all these still under sine x minus cos x all squared. Alright, we are moving somewhere. What do we do? You know, if I have this negative, you see that I close the negative here. If I were to leave this bracket and close it at the end, it means this will become positive. This negative will affect all the numbers, including this. So from here, because of the board, I'm going to leave the negative here, remove it being enclosed here. Then let me use a bracket for this. Then use the curly bracket to close it. The negative is moving all of them. Then I have a plus in there. That could have been the next step, but because we are short of blackboard, we are short of whiteboard. I'm using the blackboard, so let's see what we can do. This is negative, and this is positive. They're the same. Cos. Will it be squared in here? No, it's the twice of that, so that will not be a square. So this and this are the same, so they will cancel out because this is positive, this is negative. All right. Then we are in the same bracket. We can see that cos square plus cos square will be 2 cos square. Sine square plus sine square will also be what? 2 sine square. Let me take care of this. So if this and this are cancelled, with the negative still having effect, I'll be having 2 cos square x plus 2 sine square what? X divided by sine x minus cos x all what? Square. And here I can see you are smiling, seeing the identity, the trigonometry identity. Sine square plus cos square plus sine square equals 1. So I will factor my 2 out to become negative 2 cos square x plus sine square what? X, right? All still on sine x minus cos x all square. So in your mind, you can say that this is 1. So if that is 1, 1 times negative 2 will still mean a negative 2 all over sine x minus cos x all square. So this is our dy dx. By careful cancellation, careful manipulation, careful differentiation, we will arrive at this. Let me know what you think of this in the comment section. Let us interact together. Share with somebody who also love mathematics as fun. Let's keep growing together. Bye bye.